Hello guys, today we will see the Leetcode problem number 2943, which is maximum array of squares whole in a grid. So now let's see what is the given in the question. You are given the two integers n and m and two integers arrays h bars and v bars. The grid has n plus 2 horizontal and m plus 2 vertical bars. Okay. Creating one by one unit cell, the bars are indexed starting from 1. You can remove some of the bars in edge bars from horizontal bars and some of the edge bars from the vertical bars. So note that other bars are fixed and cannot be removed. Okay, so here it is given that only edge bars, the bars which are mentioned in the edge bars, only that can be removed, and the V bars only that can be removed, or none of the bars can be removed. Then return the integer denoting the maximum area of the square shaped hole in the grid after removing some bars, possibly none. So we can remove some of the bars, and and it is given that we can only remove the bar which are present in the edge bars and V bars. So in this example it has given the bars. Okay, let's see this example. Okay, yes, so this is the example which is given to us, sample test cases. So in this example it has given the n and m, which n represents the number of edge bars and the m represent the number of V bars. So n and m only represents that there are n vertical bars, n plus 2 vertical, n plus 2 horizontal bars and m plus 2 vertical bars are present there. Okay, so why plus 2 is there? Because here 2 is there, 2 is only the vertical bar present, but the boundary we have to assume that boundaries are always present there. Okay, so boundaries, this 1 and 3, and here in horizontal 1 and 4, these are the boundary bars which will always be present. So that's why n plus 2 and m plus 2 is given. Then we have to remove any number of bars from edge bars and V bars. It can be 0 also, and we have to figure out that what is the maximum area we can get by removing those bars. Okay, so just in this case we have removed the bar, the horizontal bar 2, by which we can get this area. We can get this area which is 2 by 2. So 2 into 2, we will get the 4 as an answer. So that's why our output we get as a 4. Okay, then how we will figure it out? How we got this answer? So in this question we have it has given the edge bars we can remove and V bars we can remove. Okay, so we have to figure out how many number of bars will be a continuous bars. Okay, the continuous bars we can remove. If let's take this example as, okay, let's take this example. Okay, 1 2 3 4 sorry 4 5 and 6. Okay, now again horizontal bars are also present there. Okay, 1 2 and 3 and 4. Okay, in this way the bars are present here. Okay, now we can remove okay, so edge bar do not contains all the bars which are horizontal bars. Edge bar array only contains that bars which we can remove. Okay, all other than that all the bars will be fixed. Okay, we cannot remove other bars. Okay, so let's say in the edge bar we have this one and this one, this one and this one. Okay, and in V bar we have this one and this one. Okay, let's take as an example 3, 5 and 6 we can remove them. 2 and 4 we can remove them. Okay, now we can remove them. So we will now try to remove 3. Okay, we can try to remove 3. So after removing 3 we get to know that we are having this area. Okay, this area, this whole area. So how much area it will contain? Which is 3 by 2, which is 3 by 2, which comes to the area as a 6. Okay, then if we are removing 3, then if we are removing 5, oh sorry, we cannot remove 6, that's why it is not given there. Okay, we can again make one more vertical line. Okay, 7. Okay, then we can remove now 6 also. Okay, we can remove 6 also and we get this. Okay, now after removing 6 we get to know this 1, 2 and 3, 3 by 3 area, which is 9. Okay, so after removing 2 we get the length as a 3. After removing 1 we get after removing this 1 we get length as a 2. So in this way, if we remove 1, so we get length as a 2. If we remove 2 we get 3. If we remove 3, so we get 4. So in this way we get one more block. Okay, after removing 1 we get after removing the n continuous lines we get n plus 1 length or breadth. Okay, of that rectangle, of the empty rectangle. Okay, in this way we get n plus 1 size of the rectangle. Okay, so now after removing this we can remove 2 and sorry, we cannot remove 4, so we will add here the 5 also. Okay, we will add here the 5 also. Okay, okay, now we can remove 2 or we can remove again 4 also. Okay, so here we have removed the 4 also. Okay, so after removing this 4 we can get this 2. Okay, get this 2 as a length, and the continuous length we can get is this. Okay, this as a 3. So we have to figure it out how many continuous means continuous when we are removing this. After removing this also we get to know if we remove 3 also. Okay, if we remove, just in case if we remove 3 also, so we get to know that whole this is considered as the length of the rectangle. Okay, so from this example you will get to know that the continuous numbers, continuous bars, continuous horizontal bars and continuous vertical bars gives us the length and the breadth. Okay, because if we remove this one, so it will affect all the horizontal bars. Okay, which are present 5u6 or which are present as a 2 3 also. Okay, all the bars are affected with the one horizontal bars. Okay, every horizontal bar affect the vertical bar. Okay, so in this way the continuous vertical bar which we are removing or the continuous horizontal bars which we are removing will affect the continuous vertical bars. So that's why we have to find out here. For the answer we will have to find out the continuous vertical bar, continuous vertical bars and the continuous horizontal bars, the maximum from continuous vertical bar and maximum from continuous horizontal bars, and this will return us the continuous vertical bar if we consider this as a length and this as a breadth. So the continuous after removing the continuous maximum continuous vertical bars, it will give us the it will give us the length and this will give us breadth. Okay, length and breadth. So after multiplying this we will get the answer as the maximum. We will get the answer for the maximum area, maximum empty area. Okay, so let's see the code in maximum square hole area. Okay, so here firstly we will sort it out that h bars and v bars, because constraints are not that much big, only h bar length is 100 only, so we can apply the brute force also, but the minimum optimized solution should be that this only. Okay, other than that brute force solution I am not able to recognize this. Okay, so let's see. Okay, firstly we will sort it out because we cannot know we don't know that this is they are continuous or not. So to figure it out that all the h bars array containing the continuous h bars. Okay, to figure out that how many continuous h bars we can remove, so that's why we have to sort h bar also and v bar also. Okay, then maximum vertical bar and maximum horizontal bar. So in this we can store the maximum h bar and maximum v bar we can remove. Okay, so we have initialized it with 1. So there should be minimum of the 1 because it is given that in h bar length it can be last from 1 to 100, so minimum 1 can be there. Okay, after that it has the, okay, we are running the for loop for h bar. Okay, and we are figuring out that h bar of I is equal to h bar of I minus of 1 plus 1, means in the case that's 2 3 5u is there in the h bar. Okay, so the 3 and 2, these are the continuous ones and we can remove the 2 as a continuous h bars. So that's why, but the 5u cannot be removed as a continuous. So here when the 4 is present, so 4 will be blocking our continuous empty space. Okay, so that's why the continuous empty space will be 2 and 3. Okay, the continuous empty space we will get 2 and 3, so that's why our continuous empty space will be count is initially 1, so that's why after counting 2 and after counting 3 it will be the count will be 3. So our length if we remove the horizontal bars, so our length will be count is equal to 3. Okay, so length is equal to count is equal to 3. Okay, then we will move forward. Then okay, in similar way we will count for the vertical bars. Okay, the continuous vertical bars which we can remove. After that we have the maximum. Okay, we will maximize the continuous vertical bars we can remove and the maximize the continuous horizontal bars we can remove. Okay, after that answer will be calculated by the by the maximum horizontal bars plus 1, maximum vertical bars plus 1. Okay, we can remove. Okay, and after that multiply by, okay, maximum horizontal bar plus 1, maximum vertical bar plus 1. So we will have to get the minimum from both of them, and after that minimum from maximum horizontal bars and maximum from vertical bars, because here we are getting okay, in this matrix which are given to us. So when we will remove the 2 and 3, okay, so just in case we will remove the fourth number of horizontal bars, so it will contain this much of the empty space after removing 5 and 6 also. Okay, so here we are removing two blocks, okay, two vertical bars, and here we are removing the one horizontal bars. Okay, after removing this we will get to know that how many of the continuous bars will be there. Okay, but now we are not needed the rectangular area. Here it is clearly mentioned that we will need the maximum area, which is a square shaped hole. Okay, to make the square shaped hole we will need the minimum from this and minimum from 5 and 6. Okay, so what is the minimum? Minimum means this is now rectangle, but if we are removing one from this horizontal, okay, so we have removed 4 from here, so we should remove one only from here. Okay, only one from here in the vertical also. It can be 5 or it can be 6. So after getting this will be whole 2 by 2 area. So 2 by 2 area means it is a square area. So in this way, that's why we are doing this. Is the minimum, as the minimum of maximum horizontal plus 1, maximum vertical plus 1, and the minimum from maximum horizontal plus 1 and maximum vertical plus 1. So we are doing the square by using this area of the square formula. Okay, and we are figuring out the minimum from both the continuous horizontals we can remove and the continuous verticals we can remove. Okay, so by this we will get the answer as the maximum area of square hole in the grid. So if you have any of the doubt, please comment down below. I will make sure that your doubts will be clear. Thank you.